Hi, this is Mr. Max doing Venn diagrams and set notation. So what I'm doing here in this particular slide is part 3 of 5. And the next part I am going to start with the union and the intersection of sets. And the last part I'm going to do exam exercises. This information is, as I said already, for grade 10 and 11 learners doing the Namibian secondary senior certificate ordinary level. Well, so when we are talking about Venn diagrams, we know that we have three ways that we already know how to express a set. It's either by listing the elements, that is in a roster, or listing them in a row, or by describing in words, like for example, a set of all prime numbers, or using set builder notation, or what is also known as the interval notation. Well, there is another method, and that is called using Venn diagrams. So what we do is we use a rectangle, and a rectangle, we are going to say that the rectangle describes the universal set, and this little funny squiggly E here represent the universal set. So sometimes they can also put a capital letter U, and it ultimately doesn't matter where you put that E, but you'll probably see it on the top there on the right hand side. So these A and B here, they are subsets of the universal set. In set A, you have what you have are all the integers, and in set B, you have natural numbers. So you can actually realize that when we talk about proper subsets, like what we did in our previous videos here, the B is a proper subset of A. All natural numbers that you know, counting numbers, are also part of what are integers, because integers, remember, are positive and negative whole numbers, including 0. And A, everything that is in A, all the integers, are a proper subset of the universal set. So let me just summarize quickly here. So we know that, for example, if you have the universal set such that x is a value that is less than or equal to 10, and you have got positive integers. So when you look in this universal set, you have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are all the values that is represented by a universal set. But in there is a subset of S that consists of elements 2, 4, 6, and 7. So all the elements that are not in this set, these are elements 1, 3, 5, 9, 10, and 8. They are placed outside the circle. Okay? Only the elements of S are placed within the circle. So these ones that are outside the circle are therefore the complement of set S. So let's look at an example here. So we have the universal set of elements between 1 up to 8. And then we've set R that has got elements 3, 8, 1, and 6. And set S that has got elements 2, 5, and 3. Looking at these two sets quickly, you'll see that 3 is something that they have in common. So when we represent this on a universal set, remember, on a Venn diagram, remember that we are going to have our rectangle here, and then we are going to have our symbol here for the universal set. You can put a U. So if I bring my R, set R, and then I know they are overlapping because there is an element of 3 that is both in R as well as in S. So they are non-disjoint sets. So I'm going to go ahead and put that particular element in that they share. So when I do the elements for R, I already have 3, so I'm going to bring in 1. And then I'm going to bring in 8. And then I'm going to bring in 6. So if I do the ones for set S, I already have the 3. So it's only the 2 and the 5 that are needed. Now everything that is not here, that is in the universal set, is placed outside the rectangle. So in this case, the 4 as well as the 7. And that's how you present on a Venn diagram. So let us just look at a quick thing that says that when you are dealing with uh, set R and S, they are not subsets of each other because of this overlap that you have here. Let's take a second example. So let's take a very simple thing. Let's say the universal set consists of all the sets of senses that we have. Set X consists of the sight and the taste and the touch senses, and Y consists of smell. So if we list all the elements of the universal set, we know that we have got 5 senses altogether. So when you represent this information on a Venn diagram, you realize that the two circles are not going to inter or overlap. So when you look at set X, where you have the sight, you have taste, you have touch, and set Y is all alone in there with the smell. And then there's something that they don't have in common, and we put that outside in a rectangle anywhere. So we realize that the two sets, they have no common elements, so there are no regions that overlap, so they are called disjoint sets. Something very important that you need to know about disjoint sets: when there are no elements in common, there's no overlap, and also obviously what you can see, if there's no intersection, then the intersection is the null set or the empty set. And if you have X and Y, if they have elements in common, like what we previously have seen, then we call them non-disjoint sets. Let's bring in more examples here. So here you have the universal set represented this time by a U, and it consists of numbers 0 up to 7 included. And then set E is going to consist of the elements 2, 3, 5, and 7. Now what they're asking you essentially is you're supposed to list the set of the complement of E, the things that are not in E. And it's very easy. You go to your universal set and you look at what is not in E. You realize 0 is not there, 1 is not there, and 4 is not there, as well as 6. So when they're asking you the number of elements that you have in set E, again, you just go and count those number of elements or the members of set E, and you realize there are 4. And when you are also asked to find the number of the elements of the complement of set E, well, in this diagram it shows them nicely, they are also 4. When you want to find the number of the elements of the universal set, the whole set together, they are all in all 8. Well, this is something that I said previously. When you're dealing with common numbers, the Q represents rational numbers, the Z represents all the set of all the integers, positive or negative integers, the N represent natural numbers. So whatever is outside here is what is not in this particular set, but they all belong to the set of real numbers. So this is how one can list or illustrate this detail on a Venn diagram. So again, we know that 16 is a natural number. So let's talk briefly about what we already discussed in our previous videos about the complement of a set. So let's take another example. We have, say, the universal set consisting of elements 1, 2, up to 9. And then we have set A, which consists of elements 1, 2, and 3. And set B, which consists of elements 6, 8, and 9. And set C, which consists of the elements 3, 5, 6, and 7. So we are supposed to list what is not in A, and that is very straightforward. So you look at what is not in A by looking at the universal set, and you realize that 4 and 5 and 6 and 7 and 8 and 9 are not in A. All the elements that are not in A except in A. Then the same for B. You look at all the elements that are not in B. So everything that is not 6 or 8 or 9 from your universal set, and it's the 1, 2, 3, 4, 5, 7 that is indicated here. When you look at all the elements or the complement of set C, these are going to be everything that is not in C. Again, the 3 is here, the 5 is here, 6 and 7 is here. So what is not there is 1, 2, 4, 8, and 9. A second example, we have here the universal set which equals to x such that x is numbers that are less than or equal to 30. What we also know about these numbers, they are elements of all positive integers. Remember, positive integers are positive whole numbers. And we have set A, and set A are prime numbers between that are less than or equal to 30. So the first prime number is 2, and the last prime number I expect in that list, if I was to list it, is going to be 29. And the multiples of 5 is going to be less than 30. Perhaps one can quickly write them down here. So when we look at the prime numbers, and I'm just going to list them, so 2 is a prime number, 3 is a prime number, 5 is a prime number, 7, 11, 13, then we have 17, 19, we have 23, and 29. These are all the prime numbers. I hope I haven't left out anyone. And when we look at the multiples that are less than 30 or equal to 30, we expect something like 5, 10, 15, 20, 25, as well as 30. So in this particular set B, these are the listed elements. Now, odd numbers that are less than 30, well, they are quite a lot. So 1, 3, 5, 7, all the way until you realize the last odd number, which happens to be 29. So we expect an overlap of some sorts to apply whenever we represent this information on a Venn diagram. So I'm just going to go ahead and take this off because I'm going to bring in my Venn diagram now, because they want us to represent or to display this information on a Venn diagram. So when I bring in the Venn diagram here, you'll see that I have got 3 overlapping sets here, and the universal set symbol is also appearing, albeit at the bottom here. So if I bring in all the prime numbers like what I've listed before that goes in set A, I know that I have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Could be maybe I missed one when I was listing. But when I imported in set A, what you have here are all the prime numbers. Now there's a reason why I have listed the other ones in black here and blue. The information is pertinent. It's going to appear more clearer. So let me bring in the elements of set B. Set B, we have got multiples of 5 that are less than 30. So 5, 10, 20, 30. There is 15 and 25 that is missing. But I need to know that because in set C, we have to have all the odd numbers. And all the odd numbers from 1, 3, 7 up to 29, 5 and 15 are also odd. And that is how we enter them there. Now there are some numbers that are not part of whatever we have here, and they are going to be appearing on the outside of the circles inside the rectangle like so. So this is how you display this information about these 3 sets and the universal set on a Venn diagram. Right. Again, I'll emphasize the importance of doing these exercises that you see on my Google Classroom. And if you want to join my Google Classrooms, you can join them by applying the following codes for grade 10 and the codes for grade 11. And if you don't know how that particular app look like, it's green with a yellow overlay. Don't forget to subscribe and click the bell, the notification bell on my channel.